Hey, it's Mr. Allred. We've been talking about exponential functions. Now we're going to do some with interest functions. So basically, you put money in the bank and it earns interest, or you borrow some money and you have to pay interest. But we have two main types of interest we're going to look at. The first one is called compound interest. And the formula down here is A of t equals P times, in parentheses, 1 plus r over n, and that's all raised to the n times t. In that, t is for time, usually in years. The a of t is the output with the interest, so that's the total money you would either end up paying or getting back. P is the principal, that's your starting amount. R is the interest rate is a decimal, and we'll see that in the examples, how to handle that. And n is a number of periods in a year. Over here with the continuous interest, which is the other formula, it has some things you may not have seen before, but it's A of t equals P times E raised to the RT. Everything over here stands for the same thing. T is the input in time, usually in years. A is the output with the interest. Then P is the principal, the starting amount. R rate is a decimal. And this E here that you may or may not have seen before in your life is a constant number. It's on your calculator, just like pi. So if you need some help with the calculator, reach out to me. Okay, so let's do a couple of examples so we can figure out how to pull this information together. So, example, Amy places $42,000 in an account that earns 2.5% interest compounded monthly. How much will the account be worth in 10 years? So we do see that word compounded, and we'll see that kind of in all the problems usually, but this here monthly. Monthly kind of describes a period. So we're going to go with the compound formula. And you'll see how to distinguish between the two in a little bit. So the formula was A of t equals P times 1 plus r over n raised to the n times t. So let's see if we can identify what we have. We're trying to figure out the ending amount, so we don't have A, but we do have a starting amount. You can look back at the formulas if you like. The starting amount P is $42,000. The rate is 2.5%, but what we're going to use is this percent as a decimal, so we'll use 0.025. So if you need to talk about how to turn percentages into decimals, you can either divide by 100 or move the decimal place over to the left twice. But if you need help beyond that, let me know. N here is the number of periods per year, and since it's monthly, it will be 12 for monthly because there are 12 months in a year. And the T will be 10 years. So our job is to put all that in our function. Okay, A of 10 for 10 years equals 42,000 times 1 plus 0.025 over 12, all raised to 12 times 10. So now this has got to go in the calculator. It takes a little bit. You can pause this if you like. And if you need help getting the calculator, don't feel bad about reaching out. Maybe I'll post something else if there seems to be a common question. But it looks like the amount I'm getting, the total with the interest, is $53,915. Since we're talking about money, I'm going to take it to the nearest penny, and 4 cents. Okay. So very important that you're able to get these numbers from the calculator. Next example. Mary invests $5,000 in a CD that grows at a rate of 4.35% compounded quarterly. So again, there's compounded, but it says quarterly, which is periodic. how much interest will she earn in 5 years? So this is a little bit different question in the end, but we only have the one formula for what we're working with, so we'll get there. So the formula again we're going to use is that compound interest formula. A of t equals p times 1 plus r over n raised to the n times t. So let's see what we got. Mary has a starting amount, AP, of $5,000. She has a rate. It's 4.35%. We're going to go ahead and move that decimal over to 0.0435. The N, quarterly. How many quarters are there in a year? There's 4. Okay. So not the length of time, but the number of times that would be. So if you were getting a statement from the bank quarterly, you would get 4 of those a year. Think about it that way. The T is 5 for 5 years. So let's plug everything in. So we're going to have A of 5, just as our reference, equals 5,000 times 1 plus 0.043 over 4 for quarterly, raised to the power of 4 times 5. So again, we're going to put that in the calculator and see what we get. 5,000, I'll be quiet. And if I don't mess up, I'm getting back that in 5 years, she should have $6,192.20. And that's the total amount. But the question was the interest. So we're going to take away the $5,000 that she started with, and she will have earned $1,192.20 in interest in 5 years. Okay. So these two formulas that I showed you are going to take you to the total amount that you would have. If you just want the interest, you'll have to take away the starting amount. The next one, Devin places $14,000 in an account that earns 5.245% compounded continuously. What would the account be worth in 18 years? Okay, so it says compounded, but it says continuously. So that means we're going to use the continuous interest formula, which was A of t equals P times e to the RT. So let's identify the pieces that we have. What does Devin have to start with? He has $14,000. That's our P. Our R, 5.245. We're going to move that decimal over, so 0.05245. And for how long? T is 18 years. So there's less information you need here. So as we set this up, A of 18. So maybe he's putting some money away for his kid who will that was just born and will hopefully go to college in 18 years. So 14,000 times E raised to the 0.05245 times 18 power. All right. So as I keep saying, consistently see if you can put the values in that I give you and get back what I'm asking you to get out of the calculator. Because if you can't get it from the calculator, it's not going to go anywhere. And hoping I put this in right. Oh, it's a nice number. It says $35,986.98. So this was a much longer period of time that we've seen before. Also a little bit better interest rate than the other problems. So it grew much larger. Okay. Example. Sherry finds an account that earns 3.75% interest compounded continuously. That tells us what formula we're going to use. If she places $22,500 in the account, what will it be worth in 6 years? So we're using that continuous interest formula again. A of t equals P times e to the r times t. So P equals 22,500. R, we're going to move that decimal 2 places, so it'll be 0.0375. And then T will be 6 years. A little messy there. But let's plug everything in. So A of 6 equals 22,500 times e to the 0.0375 times 6. So let's put that in our calculator and see how much money she will have in 6 years. And I'm getting a total of $28,177.26. Again, I deal in money unless you're told otherwise. I take it to 2 decimal places, meaning pennies. All right, thank you.